All right, now let's set up the model for origin, transshipment, and destination. Okay, so let's make that into destination. Okay, the capacities are that. Okay, and that'll be for Toronto and Detroit, right? Then we have uh, Chicago and Buffalo as the transshipment points. And then we have New York City, Philadelphia, and St. Louis as the three destinations. And the demand for destination is in a row, so we have to use transpose of these three numbers, close parenthesis, control shift enter. Okay. All right, so now we need to do sum if. Sum if the range, the first one is if range, which is that. Okay. Absolute reference that, comma, the criteria. Okay, so we don't have to use matched here because sum if will match number or text or anything. So, and then the sum range is that. So that will give us what gets out of Toronto, and that should be less than or equal to the capacity. Okay, to copy that. Okay, that's good. Now the net flow, okay, so that is what is coming into Chicago minus what's going out of Chicago, right? So you need to, when you use Chicago as the destination, then that means units are coming into Chicago. Chicago is the destination. And when you use Chicago as the origin, then that will be quantity going out of Chicago. So you need two sum ifs. So sum if, okay, range, okay, with Chicago being the destination, okay, press F4, okay, and then the criteria is that, comma, then add that. That will be again absolute reference. So this is Chicago as the destination. So this is units coming into Chicago minus sum if. Now use origin, Chicago as the origin. Okay, again absolute reference that. Okay, and the criteria is Chicago, and then that. Again press F4. So this will be the net flow. What is coming in minus what is going out. Suppose if there is a warehouse loss, for example, if it is petroleum oil that you're transporting, there is a intermediate point, and then there is some loss. So we can then multiply the what's coming in by the percentage of 1 minus the loss percentage, and then set that equal to the output. And then that's how you will take into account any warehouse losses. But here we are not assuming any warehouse losses, so what's coming in is going out, and that should be equal to 0. So what's coming in is getting out. Okay, that should be 0. And then net inflow is again another sum if. Okay, now this destination will give us what's coming in to a node. So press F4, comma, the destination city, comma, sum the flow. F4 again to absolute reference. That should be equal to 450, right? And 350 for Philadelphia and so on. Okay, now the cost of transportation is some product of shipping cost and flow. And that is our objective function. Change the color coding. Solve. Total cost should be minimized. And flow is the changing cells. And the constraints are outflow from plants should be less than or equal to capacity. Net flow must be equal to 0. We can enter a number 0 if you like. That's not a problem. Okay, inflow should be equal to demand. Okay, so here the demand is what? 1100, capacity is 1500, so that's good. Otherwise there will be a problem, so you have to have dummy supplies. Simplex LP, solve, and we have the answer. Okay, now if there is a limit on how many units the warehouse can handle, okay, suppose if Chicago can handle only 500 units and so on, something like that. So then you'll have to set up not, you need net flow to make sure that what's coming in is getting out, but you also need what is coming in, and then have an additional constraint that what is coming in should be limited to the capacity of that warehouse, whatever the capacity may be.